The second part of this activity that we have is the product of powers. We are going to see some examples, and then we are going to solve the activity that they are asking us to do. For example, same base and same exponent. So what we have for this example, as we saw in class, we need to simplify 8 to the second power to the third power. So it's what I mentioned in class, is the power of a power. So one way, the one that we went over, is multiply the base with the first exponent, the number of the exponent outside. So 3 times 8 to the second times 8 to the second power times 8 to the second power. This means that you have to multiply 8 times 8 times 8 times 8 times 8 times 8. And then you count 1, 2, 3, 4, 5, 6. So it's 8 to the 6th power. Now, what is the other way that we have? Okay? So we have 8, 2 to the third power equals to 8 to the second power times 8 to the second power times 8 to the second power. Then the bases are the same. Remember the property that if we have n to the a times n to the b is equals to n, same base, a plus b. That's one of the properties. So in this case, you have base is a, and then we add, well, there is a mistake here in the book, because if we solve this one, we will have 2 plus 2 plus 2 equals 6. We got the same answer. So in this case, what we are going to do is 8, I'm going to do it here, 8 to the second power to the third power. Remember the formula, if you have n, a to the b power is equals to n a times b. A times b. That's the formula that we are following. So this is equals to 8, 2 times 3. Exactly the same way we have it here. So this steps is different. Equals to 8, 2 times 3 is 6. Okay, we can do that one. And then we have simplified the following problem. So we have 2 to the fourth power, 5 to the fourth power. Remember the way that they are showing us to do is we develop 2 to the 4 is 2 times 2 times 2 times 2. 5 to the fourth power is 5 times 5 times 5 times 5. Then we pair 2 and 5 in group of, in this case, the exponents are 4. So 1, 2, 3, 4. 2 times 5 is 10, times 10, times 10, times 10. How many 10s do you have? 10 to the fourth power. Remember the formula. I'm going to write the formula here. So you have a to the n times b to the n. So you have the same exponent, but the bases are different. Is equals to a times b to the n power. So that reason why the other way that we have here is 2 to the fourth power times 5 to the fourth power equals to 2 times 5 to the fourth power. 2 times 5 is 10 to the fourth power. Okay, now let's look at the following problems. So we have the expression a 2 to the third power in the example problem is a product of powers. So we multiply the exponents. What are the powers being multiplied? Okay, that's question number 1. What are the powers being multiplied in the expression 2 to the fourth power times 5 to the fourth power? So we have 2 questions in one. So in this case, you can write the powers being multiplied in 8 to the second power to the third power, or 8 to the 2 and 8 to the 2 and 8 to the second power. Okay? Because we are multiplying this base 3 times. So those are the powers being multiplied. So in this case for B, the other question, what are the powers being multiplied in the expression 2 to the 4 times 5 to the fourth power? In this case, the powers being multiplied in 2 to the 4th power, 5 to the 4th power are 2 to the 4th and 5 to the 4th power. Okay? Then they are going to ask me, simplify 7 to the 5th power to the 6th power. Write your answer using an exponent. So in this case, what I'm going to do is remember the formula. So I have n to the a to the b power equals to n a times b. So I have 7 to the 5th power to the 6th power is equals to 7, 5 times 6. Where is that multiplication? It's equals to 7 to the 30th power. So that's the solution. That's what we are looking for. Number 3, simplify 6 to the 3rd power, 9 to the 3rd power. Write your answer using an exponent. Remember, now let's look. The bases are different and the exponents are the same. So I'm thinking of a to the n power times b to the n power, where the bases are different, the exponents are the same, equals to a times b to the n power. Okay, so in this case, we're going to multiply 6 times 9. So I'm going to have 6 to the 3rd power. I'm going to write this one again. 9 to the 3rd power equals to 6 times 9 to the 3rd power equals to 6 times 9 is 54 to the 3rd power. That's number 3. Let's do number 4. Okay, let's do number 4. So I have, is the statement 3 to the 5th power to the 4th power equals to 3 to the 4th power to the 5th power true? Explain your reasoning. Okay, I'm going to say yes. Okay, this is true. Yes. Why? Now I need to explain the reason why those are true. Okay? So if you have 3 to the 5th power to the 4th power, okay, this is equals to 3 to the 5th, 3 to the 5th, 3 to the 5th, and 3 to the 5th power. If you get these together, that means same base, you add the exponent. 5 plus 5 is 10, plus 5, 15, plus 5 is 20. So this one is 3 to the 20th. 3 to the 20th. This is 20, okay? 3 to the 20th. Remember, if you have 20, it's equals to 5 times 4. But also, 4 times 5 is equals to 20. So we can write these powers as 3 to the 4th to the 5th power. So what I'm going to have, so this is equals to 3 to the 4 times 3 to the 4 times 3 to the 4 times 3 to the 4. 1, 2, 3, 4. Now is 5. 3 to the 4 equals to 3. 4 plus 4 plus 4 plus 4 plus 4 equals 20, which is the same solution. So in this case, both expressions are the same. They give you the same answer, okay? So that you can write those steps as an explanation. Okay, let's turn the page around. So we have more problem. So solve. And number 5 is saying simplify 7 to the 5th power, 4 to the 5th power. Write your answer using an exponent. So I'm going to have 7 to the 5th power. I'm going to write this one again. 4 to the 5th power equals 2. We have the same exponents. Bases are different. So I remember the formula. A to the n, b to the n equals to a times b to the n. And then I'm going to proceed to do 7 times 4. So this is equals to 7 times 4 to the 5th power And I know that 7 times 4 is 28 to the 5th power. And that will be my solution for that problem. Let's do 6. Explaining words how to simplify 156 to the 2nd power to the 7th power. So one possible explanation can be, in this case, keep the base. We keep the base. Remember, that's the formula. Na to the b equals to Na times b. So I refer to the formula every time. So the base is the same. We are keeping the same base. So keep the base, okay? Okay, in this case is 153, and multiply in this case the exponents, which is in this case 2 and 7. So what will be the solution? What will be the solution? So you have, let me change the color here. I'm going to have 153 to the 2nd power to the 7th power. Following this formula, base is the same. We keep the base, 153, and then we multiply the exponents. 2 times 7 equals to 153 to the, what is 2 times 7? In this case is 14. And that will be the solution for that problem. Okay, let's move to the next one. So I have number 7. Is the statement 10 to the 5th power times 4 to the 5th power equals to 14 to the 5th power true? Explain your reasoning. In these problems, you just need to write a counterexample. Counterexample is like if you know something is a lie, you said, no, that's a lie. This is the truth. So if we know the property, remember, if we have the same exponent, a to the n, I'm going to b to the n is equals to a times b to the n power. Okay, number 7. So in this case, is this true? No, it is not true. Now I need to prove it. I need to write some reasoning. So in this case, if I write 10 to the 5th power times 4 to the 5th power, this is equals to, okay, following that step that we use is 10 times 4 to the 5th power, and I know if you multiply 10 times 4 is equals to 40 to the 5th power. So that will be the real solution, okay? 40 to the 5th power. So in this case, what can you write? Explain with your own words. So for example, in this case, I have a solution. When the powers have different bases, and the same exponent, okay? In this case, we're going to have the bases should be multiplied. The bases should be multiplied. 10 times 4 equals 40, and not added, because if you have 10 plus 4 equals 14, so that's the wrong step. Multiply and not added. Okay? That you can write that one as a explanation, or you can come up with something different. If you want, multiply the bases, and powers are the same. So let's move to number 8. What is the value of x in the equation 5 to the x power to the 5th power equals to 5 to the 35th power? And then they are asking you to explain a little bit that problem. Okay, so let me write it here again. So I'm going to have a possible explanation. So you have 5 to the x power to the 5th power equals to 5 to the 35th power. Remember that what I have here is the solution. The base is the same. What changes is x and 5. We know that the property is n to the a to the b equals to n to the a times b. So look at this. So I'm going to put in parentheses. So I have x times 5 has to be 35. So which number multiplied by 5 will give me 35? 7. Okay? So in this case, 7 times 5 equals to 35. So what is the value of x? X is equals to 7. Because multiplied by 5 is equals to 35. So what can I write here? The exponents of the simplified expression, okay? The exponents of the simplified expression, okay, 5 to the 35th power, is the product of the exponents of the factors 5 and 7. Okay? Why? Because 5 times 7 is equals to 35. So you can write that one as a possible solution. Okay, so number 9. They are asking me, without evaluating expressions, tell which is greater. 4 to the 4th power times 5 to the 4th power, or 2 to the 5th power and 10 to the 5th power. Explain your reasoning. Okay? So in this case, let's look at the bases. I have 4 and 5. Okay? So 4 times 5, and in the other side you have 2 times 10. What is 4 times 5? Is 20. 2 times 10 is 20. But look at the exponent. It's 4. And here is 5. Okay? So in this case, the exponents for this expression is bigger than this one. We have the same. 4 times 5 is 20. 2 times 10 is 20. But the exponents of these ones here bigger than this one. So this number will be bigger than the one in the left. So in this case, what can you say? Okay? 2 to the 5th power times 10 to the 5th power is greater than the expression in this case 4 to the 4th times 5 to the 4th power. Or you can write it in symbols. 2 to the 5th times 10 to the 5th is greater than 4 to the 4th, 5 to the 4th power. Okay? Problem number 10 for this page, and this will be the last one for this page, number 10. Nicholas says that 2 to the 6th power times 2 to the 6th power equals to 2 to the 12th and also equals to 4 to the 6th power. Do you agree? That's a yes-no question. But then they are asking you, explain. You need to explain. I'm going to say yes. Okay? I'm going to write yes. They are the same. Now remember the formulas. If you have same bases, n to the a times n to the b equals to n a plus b. And then if you have, in this case, bases a to the n, b to the n equals to a times b to the n. We multiply, okay? So what we're going to do in this case, so 2 to the 6th power, 2 to the 6th power equals to 2, 6 plus 6 equals to 2 to the 12. Okay? That's the first one. And then we're going to have that 2 to the 6, 2 to the 6 is equals to, we keep the same exponent, and then we multiply the bases. 4 to the 12 is 6 plus 6, 12. Okay? So we get the same solution, okay, in the same problem. So that's number 10. If you have any question, you can email me, or you can leave me a message in Google Classroom. Have a good day.